Hello everybody, welcome back. Today we are continuing with 5.5 Z-scores. We are on example number 2. It says the marks on a math exam were found to have a mean of 52. So mean is 52 with a standard deviation of 12. Standard deviation of 12. The teacher thought the exam was too difficult and decided to adjust the scores by raising the mean to 65. So this is the old category. We'll call this old, and we'll call it new, just to make it easier. So there's old, and then we got our new scores, and they said they adjust the mean to 65 instead. And the standard deviation was reduced to 10. Standard deviation reduced to 10. The Z-score is going to be remaining unchanged, so we're going to calculate this Z-score because it said what would the new mark for a student who received an original mark of 34. So the original mark is 34, that's X. The new mark is what we're looking for here in the second set of data, but first of all we have to find, in the old, we've got to find the Z-score and then keep them the same. So this Z-score is going to equal this Z-score. So first what we're going to do is we're going to take the old data and we're going to calculate the Z-score. So the Z-score we know is calculated by taking the given mark, which was a 34, subtracting the mean, which was 52, and dividing by the standard deviation, which was 12. So calculate that. 34 subtract 52 is negative 18, and negative 18 divided by 12 is negative 1.5. So the Z-score is negative 1.5. So we're going to use that when we calculate the new mark the student is going to receive. I had a stats course once, and this is what was done. They call it the bell curve, which is essentially normal distribution, and the professor would do this exact method when calculating your mark. All right, did some interesting work, and if you have one of the higher marks in the class, it was beneficial for sure. Any mark really, but so we're going to put that in as 1.5. Z-score negative 1.5. We're solving for X. We changed the new mean to 65. That should be 65 there, sorry. 65. And the standard deviation was 10. So we're filling that in, and now we're going to get the new mark by solving for X. So the first thing we do is multiply both sides by 10. That leaves us with X minus 65. And multiply this side by 10. And we get negative 15. And we add 65 to both sides. When we add 65 to both sides, add 65 here, 65 minus 65 is gone, and that leaves you with X equals 50. So the person that had the 34 now has a 50. So it worked out really well for this student. As the teacher adjusted the means, adjusted the mean up by 13 points, took the standard deviation down to 10, so that's going to be less of a dispersion, and the new mark is 50. The new mark is 50 on the nose. Okay. Next, we're going to look at example 3. It says when the manufacturer of bungee cords is going well, the lengths of the bungee cords are normally distributed with a mean of 45.2 centimeters and a standard deviation of 1.3 centimeters. Bungee cords that are shorter than 4.2 centimeters or longer than 48.0 centimeters are rejected by quality control. If 20,000 bungee cords are manufactured each day, how many bungee cords would you expect to be rejected by the quality of the work? So the first thing we need to do is we're going to calculate the Z-score. Once we have the two Z-scores, we'll find the probability using our Z table, and then we'll multiply that by the 20,000 bungee cords. Okay, so let's do the Z-scores. So what we're going to do is we're going to write down the information. It said the mean was 45.2. It said the standard deviation was 1.3. It gave us two x values, right? It gave us 42 for the lower part, and the high end is 48. And I'll show you how to do that now. So we're going to look for two Z-scores. And once we find the two Z-scores, because we're going to need one that's lower than 42, and we're going to need one that's higher than 48. So we'll calculate these. So I'll calculate the first Z-score, and it's going to be the x value, which is 42.0, subtract 45.2, divided by the standard deviation of 1.3. Subtract those, you get negative 3.2 divided by 1.3, and we get a Z-score of negative 2.4615. Alright, do the same thing with the second x value. So that was, the high end was 48.0. I'm going to draw a diagram for you in a minute. It'll make sense of all this. Fill everything in. And then we're going to subtract so that we get 2.8. And 2.8 divided by 1.3. And you want to take 4 places after the decimal. And the reason you want to take 4 places after the decimal is because when you're looking for these percentages, you want to get close as you can on the Z table. And the Z table has percentages of 4 places after the decimal. So that was 2.15384. So 38. Okay? So what that means is, so I'll show you where I'm getting these percentages at. So remember, when you're using the Z table, it's everything to the left. So in the first one, you just go get the value. So we get negative 2.46. So that's what we're looking for. So we go to our Z table, negative 2.46. So the negative 2.46 right here is 0.0069. So that's what I meant before about the percentage. So it's a very small percentage, not even 1%, 0.69%. That's where this value comes from, right here. And then the next one is we want to go to the right of it. So we need to take 1 minus that, right? Because remember, the Z table gives you everything to the left. We don't want the 98%. We just want the amount that's left over. So we go to our graph. We look at 2.15 in the Z table. So it's the second sheet. 2.1 and 5 is right here. So that would be 0.9842. So 98.42%. And that's right here, but again, we subtract 1 from it. We're interested in the 0.0156%. So the total percent from the left and right hand side, we're going to add them up. So we take 0.69%, right, because you got to multiply by 100 to make the percentage. This is the decimal. And then the 0.0158, so that's plus 1.58%, which is equal to 2.27%. So that's how the percentage of the bungee cords that are going to have to be rejected. So to figure out how many bungee cords are going to be rejected, so the number of bungee cords rejected will be 2.27%, which is 0.0227 multiplied by 20,000, which is equal to 454 bungee cords. So out of the 20,000 bungee cords, 454 will have to be rejected because they are lower than 42 centimeters or longer than 48 centimeters. The last example is determining warranty periods. So the example says the manufacturer of personal music players has determined that the mean life of the record players is 32.4 months, with a standard deviation of 6.3 months. So it says, what length of warranty should we offer if the manufacturer wants to restrict repairs to less than 1.5%? So we know it's going to be over here somewhere. We don't know exactly, but what we're going to do is we're going to calculate the Z-score, and that'll help us with determining how long we should offer the warranty. So we know that 1.5%, and we want it to be, it's going to be less than that, right? It's going to be 0.015. So what we want to do is we want to go look for that Z-score on the Z table. So we go on here and we try to find 0.015, and it's right here, as you can see, which is a Z-score of negative 2.17. So now what I'll do is I'll solve for X. X will be the warranty that we're going to get. So I'll fill in Z. Z is equal to negative 2.17. X is what we're looking for. The mean was 32.4. Standard deviation was 6.3. So we're going to take this, and we're going to solve for X. So multiply both sides by 6.3. Leave you with X minus 32.4 on this. On the right hand side and the left hand side do the same thing. Multiply by 6.3. Negative 2.17 multiplied by 6.3 equals negative 13.67. Add 32 to both sides. Add 32.4 to both sides. Add 32.4 to both sides. That gives us 0. Leaves us with X. That's why we did it. And when we add them two together, we get 18.729. Kind of weird to give a 19-month warranty, so we're going to round down. So the warranty should be at least 18 months, right? 18 months will do it. So that'll be the warranty we give out for the record player. Year and a half. So that's it for the Z-scores. You're going to have to really try a few of these, right, to get the hang of them. So the homework for these will be on page 264, number 5 through 9. Just do A and B, 12, 13, 16, and 17. Remember, use your Z tables that I found on the next couple of pages. Right, this is the left-hand side, this is the right-hand side. And then in the next video, we'll look at the final section of Chapter 5, which is 5.6 confidence intervals. Thanks for watching. I hope the videos are helping. We'll talk again soon.